All right, good afternoon, everyone. Today we had a quiz in class over equilibrium, and some of the questions as I'm going through and grading them, I'm noticing some consistent mistakes, and I feel as though there was some confusion as to what you all were supposed to do and how even to attack these questions. So let's go through them, and we sort of want to. In the end, I want you to realize that all the questions that were on this quiz were available to you. It was information that we've covered in class, we've done practice with, so it should not have come as a surprise or a shock when we looked at the different questions. Now, as we look at number one, it says answer the following questions that relate to the solubility of salts of lead and barium. As soon as you see that word solubility, as soon as that word enters even into the mix, what we're going to be doing is we're going to look at how, or what we call the solubility product. If you remember before, we talked about this thing and I told you you'd write it and it would be KSP. Okay? So it's going to look very much like an equilibrium expression. But one of the things that we're going to have to pay attention to is if we're dealing with a solid, like we're dealing with in this case, it says lead iodide solid, we know that it's going to be insoluble. Okay? Now, let's take a look at the solution. It gives us the information. Saturated solution is prepared by adding an excess of lead to iodide to distilled water and form 1 liter solution at 25 degrees Celsius. The concentration of the lead 2 ion in saturated solution is found to be 1.3 times 10 to the negative 3 molar. So I'm going to go ahead and I'm going to underline this because this is one piece of information I'm going to need actually very shortly. Now, the chemical equation is shown below. First part number one, write the equilibrium constant expression or the equilibrium expression for this equation. I know that I'm going to have a K value, so K, and since it's talking about a solid, it's going to be KSP equals something. Now, we know that K is always products over reactants, but what do we notice here in our reaction? Ooh, our reactant is a solid, and solids concentrations remain constant. So that means everything is going to be based on my products. So let's go ahead and continue. I have my concentration of my lead 2 ion times concentration of my iodide ion. Oops, that's a negative sign. And that's going to be squared. Why squared? Because I have a coefficient of 2 here in my equation. So that being done, that's one solid point. One solid point, sorry. Now, part two, calculate the molar concentration of iodide in the solution. This is where I'm going to go back to my value here. Notice that it said my lead ion concentration is 1.3 times 10 to the negative third. According to this, if I'm decreasing my amount or my value by this amount for my lead iodide here, and this is the concentration I have, that means my iodine is going to be twice that amount. So I'm going to do 2 times my 1.3, oops, times 10 to the negative third, which should give me 2.6 times 10 to the negative third is my iodide ion concentration. Oops. Okay. So far, everything seems very, very straightforward. There should be no major issues to be concerned with. Last but not least, calculate the value of the equilibrium constant, KSP. Well, if I have my lead ion concentration and I have my iodide ion concentration, all I need to do is now plug it into my KSP expression. So 1.3 times 10 to the negative third times 2.6 times 10 to the negative third, and that value will be squared based on our expression. At the end of that, you should come out to a value of 8.8 times 10 to the negative ninth. Now, one of the things I want to point out to you here, take a look at this number. Notice it's times 10 to the negative ninth. That means it's extremely small. Remember we talked about the solubility of certain things and we said that they will be insoluble. This KSP value is actually telling you that very, very, very little amount of this will dissolve in water. Okay? Now, the next part of the question says, a saturated solution is prepared by adding lead, uh, lead iodide solid to distilled water to form 2 liters of the solution at 25 degrees Celsius. What are the molar concentrations of lead ions and iodide ions in the solution? Justify your answer. Well, if we're looking at the information that we've already been given, we should end up with the same exact values. Notice how small of an amount dissolves based on what we've already seen. That's regardless of, or that doesn't even matter that we had a 1 liter solution here. If I make it a 2 liter solution, I'm still going to end up with the same concentration. So, the values here, just as simple as writing what you had already written for the previous 2 steps. And because again, it's based on this KSP value. It's not based on the volume of the container or any other material such as that. Last but not least in this question, oops, it says solid sodium iodide is added to a saturated solution of PbI2 at 25 degrees Celsius. Assuming that the volume of the solution does not change, does the molar concentration of iodide, lead 2 ions in the solution increase, decrease, or remain the same? Justify your answer. So we've already seen that this is the reaction that we're observing. Now, paying attention to this, when I add in sodium iodide, because we're paying attention to the solubility, I already know that my sodium ions are going to float around in solution because it's completely soluble. It has a very, very high KSP value. Now, that means what I'm really adding to the solution is just these iodide ions. Based on our discussion today, or even what we would have really considered, if I'm adding to my iodide, I'm going to increase this. The reaction is going to shift to the left. I mean, it's going to shift towards making more of our solid. Oops. Now, if it's shifting to making more of our solid, that means that I'm going to have to use up my lead ions. My hope is that that makes sense. I increase this value, which means that I'm going to decrease this value because they're both going to be used up to make more of my, in this case, lead iodide. Okay? So, I should say that this is going to decrease according to that. On the test, looking for terms like Le Chatelier's principle in the end, that's why it shifts. Again, it wants to ease that stress that's being added to the system, and then we can go ahead and proceed from there. Moving on to the second question. This one, my hope is you realize you really didn't, you could have used an ice table to go ahead and complete it. I actually think that it works a lot better if you do, but that's completely up to you. Now, it says, when heated, hydrogen sulfide gas decomposes according to the equation above. And looking at it, I noticed that one thing is missing. So if you went ahead and put that down, I did give you a credit for it. But we want to go ahead and make sure that we adjust that. So that's supposed to be a 2. Now, it's a 3.40 gram sample is introduced into an evacuated rigid 1.25 liter container, meaning there was nothing else in there except the 3.40 grams of hydrogen sulfide. The sealed container is then heated to 483 Kelvin and 3.72 times 10 to the negative 2 um, moles of sulfur are present at equilibrium. First off, just as we did before, write the equilibrium expression, or Kc, for the decomposition reaction. So it's going to be products over reactants. So Kc is equal to products H2, and that's going to be squared times S2 all over H2S. And of course, that's also going to be squared. Now, calculate the equilibrium concentration in moles per liter for the following gases. It says for H2 and H2S. Why do we not need to worry about S at that point? Well, it tells us up here what the concentration of S was, the number of moles of S were. So, what I'm going to do is use this space and I'm going to create an ice table. So, 2H2S and 2H2 plus S2. I'm going to give myself some space because you know my handwriting is kind of interesting. So, ICE. Now, it tells me that I have 3.40 grams of hydrogen sulfide. When I take that and divide it by the molar mass, I'm going to end up with, that is 0.10 moles. Now, if I have that many moles, I'm going to divide that by the 1.25 liters, and that gives me 0.80, 0.080, sorry. That's just, we'll just go ahead and put a zero. There we go. Now, at this point, when everything begins, these are both at 0. In some way, when this changes, because I have zeros this direction, I'm going to decrease by 2x. This is going to increase by 2x. And this one's going to increase by x. It gives us a hint at what's happening here, though. It tells us we have 3.72 times 10 to the negative 2 moles of S2 at equilibrium. If I take that value and divide it by the volume of the container, 1.25, I'm going to end up with 0.29, I believe. 0.029, sorry. And again, I'm verifying my work just to make sure I don't mess anything up for you guys. 3.72. 0.027 or 2976. So I'm going to go ahead and write this down in concentration form. 0.0297 moles. Now, since I know that this value changed by x, that tells me that this value is x. That being the case, I can go ahead and proceed into the next part. We said that H2 was going to be 2 times this concentration. So 2 times 0.0297 gives us approximately 0.0595. Let me go ahead and oops. We'll just go with that. Now, if this one changed by 2x and this value represents 2x, all I need to do is subtract 0.080 minus 0.0595. And when I do that, I'm going to end up with a value of 0.0205. So, in terms of the values that it asked me to find, This one was number one. This one was number two. Now, just like the ice tables that we've been working with, everything we've been doing is just working backwards. Now, last part to finish up, part C. Now that we have these values, it asks us to go ahead and solve. So, products over reactants, 0.0595 squared times 0.0297, all divided by 0.0205. This is also going to be squared. Plugging that into your calculator, you should come out with 0.250. Just that simple, very straightforward. Okay, so in terms of the information that you needed to know for this quiz, it wasn't anything different than what we've been practicing. If you're running into situations of I wasn't sure, I didn't know, I'm still working on it, you need to come in and see me. Find some resource if you can't get to me, but I'm here and available. Please, please, please utilize me as a resource. Now, I could go through and do the bonus, but I think I'll save that for another time in class. Have a great afternoon. Again, reflect on what you saw here. If you have questions, please, please, please look at this because I want you to be able to come back and to make sure you understand it. Test day is coming. It's right around the corner, so we want to make sure that you are as prepared as you can be for that day. With that being said, have a great evening, and I'll see you in class.